Have you ever wondered why the smartest AI systems in the world don't just need better software, but entirely different machines to run on? Somewhere deep inside giant data centers, engineers are confronting a problem that doesn't show up on your screen. Today's AI has outgrown the tools that once made it possible. The processors that powered the digital revolution are now struggling to carry the weight of artificial intelligence. And in response, a radically different kind of computer has emerged. One that doesn't think like a GPU at all. This is the story of why Cerebras is built differently. For decades, GPUs have been the silent heroes of the digital world. They powered video games, animated movies, and visual effects long before anyone imagined they would become the engine of artificial intelligence. When AI research exploded, engineers discovered that these graphics chips were surprisingly good at handling the heavy math behind machine learning. But GPUs were never designed for intelligence at scale. They were built to draw images, not to support models with billions of interconnected pieces, all needing to talk to each other constantly. As AI grew more complex, engineers tried to solve the problem by connecting more and more GPUs together. Clusters grew into rooms. Rooms grew into buildings. And with that growth came a hidden enemy: distance. On the surface, these GPU clusters look powerful, but under the hood, they are fragile ecosystems. Each chip has to exchange information with others thousands of times per second. Those tiny delays add up. Training large AI systems slowly becomes less about computation and more about coordination. It's like trying to have a deep conversation while everyone is shouting across different cities. The thinking is there, but it's constantly interrupted. Cerebras did not try to build a better GPU. It asked a more radical question. What if the distance was the problem? Instead of stitching together thousands of small chips, Cerebras built a single, massive chip, a full silicon wafer transformed into one unified processor. This isn't evolution, it's reinvention. Instead of forcing intelligence to travel between machines, Cerebras brings everything into the same physical space. This enormous chip is often called a brain on a wafer, and the metaphor is fitting. Instead of fragmenting intelligence across machines, Cerebras allows the entire model to live inside one environment. Data doesn't bounce between servers. It flows directly across the surface of the chip at near light speed. No bottlenecks, no traffic jams, just pure continuity. The system stops feeling like hardware and starts behaving like a living system. In AI training, coordination is everything. Billions of numbers must move in perfect harmony. On traditional clusters, that harmony is constantly broken by distance. Cerebras removes that disruption. When everything is local, learning becomes fluid. Models grow without becoming unstable. Complexity stops being a burden. It becomes an advantage. This is not just faster computing. It is calmer computing. This architecture is already reshaping science. Medical researchers are training diagnostic models that once took months in days. Climate scientists are running simulations at a scale that was previously impossible. Physicists are exploring data that would have overwhelmed conventional systems. This is not about speed. It is about possibility. Cerebras is not here to replace GPUs. It is here to redefine what intelligence-first hardware should look like. For the first time, machines are being designed around the needs of thinking, not drawing graphics, not playing games, but learning, reasoning, and evolving. When hardware is shaped around intelligence instead of visuals, the future of computing stops looking like towers of machines stacked together and starts feeling like a single unified system, one that grows smarter as a whole. That is why Cerebras is not just different. It is not an upgrade. It is a foundation. GPUs helped build the AI era, but Cerebras is shaping what comes next. By removing distance, simplifying complexity, and turning computation into a unified organism, it shows us a future where machines are no longer stitched together. They are grown whole. And that may be the biggest step forward in artificial intelligence we've ever made.